welcome back. This is problem number 5 on homework 8.2, dealing with kinetic energy and the work energy theorem. So the first thing I should probably point out about this problem is the fact that there's sort of a typo in the answer. Here's the final answer right here. As with all of our homework problems, I'll give you the answer so you know what to look for. But the problem is there is no D. There's no jogger D right here, so you can just cross that out. What we're going to be doing is ranking joggers A, B, and C in increasing order of kinetic energy. Okay, so there just is no jogger D. In this problem, however, one of the things that trips students up the most, I think, is the fact that there are no actual values. There's just kind of like general values. For example, jogger A right here has a mass of m and a speed of, or velocity of v. Okay, and jogger B and jogger C have varying forms of m and v. And it's easy to want to have numbers to plug in there, but we don't. So we won't actually know their actual kinetic energies, but we will know which one has greater kinetic energies than the other ones. And we do this by kind of writing out equations in general forms. Again, that's not natural for us to want to do that, but once we do this, I think it'll make sense to you. Okay, so let's do jogger A first, and then we'll see if it makes a little bit more sense. So we got jogger A right here. I'm going to go, let's see, jogger B right here, and jogger C right there. All right, we're going to write out what the mass and the velocity are of jogger A in terms of, well, what we're told right here. So jogger A, the mass equals, well, m, right? We're told that it's some mass m, okay? And the velocity is some velocity v. So that means that the kinetic energy, which we don't know exactly what it is, but we do know that the kinetic energy of jogger A is 1/2 mv squared, and that's really what the final answer is going to be, 1/2 mv squared. Now you might think to yourself, well, why did you write it twice? Well, in the other ones, B and C, it's going to be a little bit different, and we're going to do some calculations, but this right here is the kinetic energy of jogger A. All right, well, let's compare that then to jogger B. What does jogger B have? Well, he's got a mass of what? Well, that's m/2, right? That's 1/2 the mass. Okay, so that's the mass of jogger B, and the velocity, or the speed of jogger B, is 3 times jogger A's velocity. All right, so he has half the mass, but 3 times the speed, 3 times the velocity. All right, and while we're at it, let's just write out C as well. C's mass is, feel sorry for this guy, he has the most mass to carry around. That's 3m, whatever m is. C is 3 times that. And the velocity for jogger C is not that much. It's v/2. All right, so it's half the velocity right there. So I'll put that in brackets as well. So these are kind of like general terms that stand in for our mass, velocity, mass, velocity, mass, and velocity. Okay, so the kinetic energy of jogger B, what's that going to be? Well, it's going to be 1/2 times the mass. What is the mass? The mass is m/2, and the velocity squared. So it's going to be 3v squared. All right, and likewise, we'll do the same thing for C, and then we'll kind of simplify this. All right, so what is the kinetic energy of jogger C? All right, well, it's 1/2 mv squared. What's the m? The m is 3m, right? And the velocity squared is v/2, that whole quantity squared right there. All right, so let's go ahead and simplify these. By the way, they're all going to be in terms, my answer is going to be in terms of 1/2 mv squared. So they're going to have the 1/2 out front and an m and a v squared, but B and C are going to have different coefficients out front, and that'll make them greater or lesser than A. Okay, so what do we have for B? Well, we're going to have we have our 1/2 and our m and our v squared, but we're also going to have in the numerator a 3 squared, right? Because that's going to be 9, because that 3 is squared as well as the velocity squared, so that's going to be 9. And then in the denominator we have this kind of lone 2 by itself. All right, so that's going to be 9 over 2. So there's our 9, and there's our 2, and everything else is the 1/2 mv squared. 1/2 mv squared, like so. So that simplifies to, what is 9 over 2? That's 4.5, right? 4.5 times 1/2 mv squared. Now, I guess you could probably say, I'll put that time sign out front, make it more of a dot, I guess. I guess you could probably say that you could combine that with the 1/2 and reduce that down to 2.25 mv squared, but I want 1/2 mv squared to be in all of our answers right here, so we can compare them kind of apples to apples. All right, so obviously right off the bat, B has got 4.5 times the kinetic energy as jogger A. All right, because there's a 4.5 out front. In fact, I'll put that in brackets right there. 4.5 times 1/2 mv squared. A heck of a lot more than A. How about jogger C? All right, well, we have, let's circle our 1/2 mv squared. So we got our 1/2 m and our v squared. Okay, so let's just go ahead and write that. It's going to be something 1/2 mv squared. 1/2 mv squared. What's going to be out front, however? Well, we have a 3 here in the numerator. So there's going to be a 3 right there. But look, we have down here in the denominator, we've got this 2 that's going to be squared. And so that's going to be a 4 that winds up in the denominator. 3/4 1/2 mv squared. So that simplifies down to 0.75, put that out front, times 1/2 mv squared. Again, if you had actual values right here, you would definitely combine that with the 1/2 and then plug in whatever your m and whatever your v is. But the point here is that like I said before, I'm comparing them apples to apples, so that they all have 1/2 mv squared, but obviously this is the least, right? Because 0.75 is less than 1. All right, so this one right here is going to be the middlemost, and this is going to be the greatest amount of kinetic energy. And that's what we have right here. C is less than A, which is less than B. And of course there is no D, but we said that before. All right, so that's how we rank different varying kinetic energies in general terms, not with any known given values. So that's problem number 5 in homework 8.2. Hope that helps. Come see me if it doesn't. I'll see you on the next one.